Hello guys, we've got a fairly difficult derivative question for you today, more difficult than you're likely to find on a methods exam. So it gets a red traffic light. However, it's challenging. It's a good idea to be able to do these kind of questions because to be able to answer a question which is at a higher level than you're likely to be asked gives you more confidence to be able to perform at 100% for the questions that they will ask you about on the exam. Okay, so let's have a go at this. Y equals sine of e to the x squared minus x to the minus 2. So it's a chain rule question, of course, and this is a beast, isn't it? So what we do is we just remove all of the pain and anguish that's causing us by letting it be y equals sine u, where u is e to the x squared minus x to the minus 2. Now, we just peeled the onion, as I say to my students, one layer, and we've said, okay, y is sine u. We can easily do dy du because that would be cos u, and then we deal with the next layer down of the onion, this one. So now we've got u equals e to the something also fairly dreadful, and we call this fairly dreadful bit because we know how to do the derivative of e to the x, and this is not e to the x, it's e to the something else, some function of x, and we'll call that some single symbol again. Okay, so why not call it v? So this u could now be e to the v. dy du is cos u, and now we're dealing with the next layer of the onion down. So u equals e to the v, okay, where v is this thing here. And we know, of course, that du dv is e to the v, as I was saying, and then we can deal with this layer of the onion, okay? Right, now, this layer of the onion probably doesn't need any more symbols because we can just do the derivative of that without any trouble at all. In fact, dv dx would be, what would it be, guys? Come on, be 2x plus 2x to the minus 3, wouldn't it? Yes, let's go for that. So 2x plus 2x to the minus 3. So we don't need to peel the onion anymore, and we can now set up our chain rule equation as follows. Watch this. Very exciting. dy dx equals dy du times du dv times dv dx. It's a 3-layer chain rule. What a beauty, eh? And we can just substitute what we found above for each of these derivatives. dy du was cos u, du dv was e to the v, and dv dx was this one here. So let's put that in and see how we go with that. So we've got cos u times e to the v times 2x plus 2x to the minus 3, haven't we? Now, the last little step we've got to go through to get this sorted is substitute back for the symbols which we invented here. So what was u? Oh, here it is, in terms of x, that is. U is e to the x squared minus x to the minus 2. So we put that in there for that u. Now e to the v, v in terms of x is up here, x squared minus x to the minus 2, times this thing here which is already in terms of x. So then everything will be in terms of x and everything will be very, very exciting and worth full marks. So off we go. We've got cos of, what was that thing again? Cos of u times e to the v times that last little bit there, and I think we can put a box around that after we clean it up a bit and make it look a little bit nicer. And that's looking much nicer. And there's the box. It's beautiful, isn't it? So just remember about peeling the onion, guys. You basically find whatever is objectionable, because you're used to doing, say, sine x. Well, it's not sine x. It's a sine of a function of x, and you call that function of x a single symbol, u, and then you go from there. And then you keep peeling. You keep peeling all the way down until you get a derivative which is easy to do, which we did at this level here in this case. And it just becomes very easy to do multi-level chain rule questions.